Now that we've finished this module, let's summarize what we learned in this module 20, the beginning of this unit. First, when data is quantitative, it's summarized with a mean and a standard deviation as opposed to a population proportion. Secondly, when selecting random samples of size n from a population with mean mu and standard deviation sigma, the resulting distribution of sample means is our probability model. It has the following properties. First, the mean of the sampling distribution of means is mu. Second, the standard deviation of the sampling distribution is called the standard error. It's equal to sigma over the square root of n. And we noticed previously in this module that if as n grows, the standard error of the sampling distribution of means shrinks. It means that larger samples give more accurate estimates of the population means. We also saw that the central limit theorem states that for large enough sample sizes, the sampling distribution of means is approximately normal, even if the population is not normal. If a variable has a skewed distribution for individuals in the population, a large sample size is needed to ensure that the sampling distribution has a normal shape. The general rule is that if n is more than 30, the sampling distribution of means will be approximately normal. However, and 30 is always the magic number. It's from the central limit theorem, no matter what example you're looking at. However, if the population is already normal, then any sample size will produce a normal sampling distribution. So it's if you already have a normal or approximately a normal distribution, you already know it's normal, then the size of n, the sample size, doesn't matter at all. You can do anything, and you can still use a normal model to infer things. But if you're not sure if your distribution is normal or not, just make sure your sample size is greater than 30, and you can use a normal model to do your analysis. When the sampling distribution is approximately normal, we can calculate a z-score and use the standard normal curve to calculate probabilities, as we saw on the previous page. We'll convert a sample mean x bar into a z-score with this formula, very similar to the old one, except now it's the x bar, the sample mean, minus mu, the population mean, divided by not just sigma, but sigma over the square root of n. We then use technology like an applet or a graphing calculator or some website that does it for us. Use technology to find a probability associated with the given range of z-scores.